Welcome to the second PowerPoint training video. This is just going to be a brief introduction to cabling and the many aspects of it and what you can do with it, the types of it. So let's begin right here, and we'll begin with twisted pair. We're going to be discussing both cables and connectors, which are very, very common. However, when you get to fiber, there's a great many different types of connectors, so we'll talk about them. Basically, here are some key terms to look at: crosstalk, UDP, STP, plenum, and riser, and you'll see what each one of those are. Crosstalk is usually some kind of leaking of data, and you'll see that in the cable in the twisted pair, and that is why the pairs are actually twisted. UDP stands for unshielded, STP is shielded twisted pair. The most common is going to be UDP or unshielded twisted pair. Plenum space, please forgive me, still have a little bit of leftover from my cold and flu last week, so I'm having a little bit of difficulty speaking. So please, again, bear with me in that. Plenum space and riser space, those are the spaces that you needed to run cables. You'll see the plenum space is normally above in a drop ceiling, and the riser space is between floors. Crosstalk, again, is unwanted transfer signals between communication channels. You'll see that in a picture of an unshielded twisted pair. And again, we talked about UDP and STP. You're going to want STP if it's really very important, because it does give some extra protection. And again, we talked about plenum space, which provides a pathway for airflow needed by heating and cooling system, and it's a drop space ceiling or a raised floor. Riser space is going to connect different floors in here. So then here you see the plenum space up top over here, can also be on the bottom as said. And this is your twisted pair. Notice that there are 4 pairs or 8 wires altogether. This is solid, and you can see that there's crosstalk that can be in here. This is why the tighter the pairs are wrapped, the better protection against crosstalk. So then we have the advantages. It's very flexible. You can bend it. You can do whatever you want with it. It's not very expensive. It is very easy to work with. You just snip it. The pairs come out very easy, and it's upward compatible with no particles. So you can see the twisted pair offers a little bit extra protection. It's got the foil over here, the sheeting, and a drain wire. The things about this twisted pair that is not good, again, susceptible to interference, susceptible to eavesdropping, if somebody can try to get your data. Plenum space we talked about in here, and riser. So you can see twisted pair is going to connect signals better, and it is a little bit prone to breaking, but be honest with you, have never had one break that I needed. Maybe the ends break from time to time when you're doing something, but it's very, very, very rare. So you can see that you have the solid and the stranded. Most common is the solid. So you have Cat3, which is old telephone wire. Cat5 and Cat5e are the most common right now. Cat5e is the same as Cat5, only it's twisted tighter for better protection. Cat6 and Cat6a are really the new standard for most new cables, and 7 is upcoming. So you can see how you have 4 pairs and they're twisted around each other. These are the different jacks. The RJ11 is phone jacks. The RJ45 is the most common. And then you can see the GG45 and the Terra. And I've given you a little bit of examples in upcoming slides of the new ones. So GG45 is used as basically like a RJ45. It's backwards compatible, and it's used for the high-speed Cat7. Terra, again, is basically the same thing to use with Cat7 and has a different footprint than the common 8-piece and 8 connectors. So twisted pairs, again, reduce crosstalk. Shielding reduces EMI phase. Plenum cables for plenum spaces. Categories 3 to 7. Basically 5, 6, and 7. Cat3 is really out because it does not offer enough speed. And RJ11, 45, and the GG and the Terra. The most common is going to be the RG45. So Then again, you're going to do a lab, connect to an Ethernet library or Ethernet network. And these are class discussions that you can just look at and make sure that you understand how each and every one works. Here's coaxial cable, and really the only thing that it's used for nowadays is for your cable TV and maybe your satellite TV. There's not going to be any networks of any consequence that are going to be using coaxial cable. So basically, you're going to connect a Canadian modem, and you need to know the terms PVI, EMI, and BNC. So basically, PVC, again, you all know what that is. It's a type of plastic. Most commonly, you see it as cables running through it and maybe even pipes. EMI is electromagnetic interference. And BNC, called the bayonet Neo, it's a type of connector that you're going to use for RJ58 cable. And you can see this is actually the type of connectors that are used to connect into a coaxial network. This is what it actually looks like from the inside. And the advantages, resistant and resistant to physical damage. However, the disadvantages way outweigh the advantages. Expensive, relatively thick and harder to install. RJ58 is what the old cables were, and then the cable TV is now running RG59 or RG6, which is better. So you can see the BNC connector, a coupler, and this is an F-type. So again, here's your summary. Then you're going to connect a cable modem for a simulation. Know these things in here. Fiber optic is definitely much more complicated and not very easy to work with. So basically, we need to understand how these are. LED is, you know, we're familiar with LED. It's light emitting diode. You see that in TVs. You see that in monitors. WDM is basically what we're using for in the fiber optic cables, called wave division multiplexing, as you can read. And it basically just joins several light waves, colors into a single strand of fiber. So you can see in the next upcoming slides exactly how that lets it work. Then most important is light allows signals to go back and forth both directions in a single fiber. And it's generally used in single fiber mode, which is going to be for long distance. So you can see how complicated the fiber is. So you have a glass or plastic core, you have what's called cladding, which is used to redirect the signal. It's immune to EMI, which is great, and you're going to have high data transmission rates, up to 10 gigabytes. Disadvantage is obviously very expensive, difficult to work with. It's not easy to connect fiber cables. So the single mode and multi-mode differ. Now one is very thin strand, one is much more thick, and you can see that the single is going to be confused with multi. You would think that single would offer less speed than multi, but it's actually the other way around. Single path, multiple paths. Single mode, less affected by modal dispersion. You can do a longer distance. So you're going to use single mode mostly going from your demarc out. The multi-mode is going to be for short distances, say between floors or between buildings. This is how wavelength multivision multiplexing works. This is an example of it. So you can see it comes in, it gets transmitted into a single strand, and then it goes out and spreads out. And you can see it can transmit up to 16 terabytes per second, which is pretty high. These are the different connectors, ST, which is usually a bayonet, the SC connector, which is 2 and 1. Both use a single keyed. You push and twist, and the connector is nickel plated to ensure that it stays in place. So basically, you're just going to push it in and twist it. SC is both single and multi-mode. You push it in and pull it out. It does have a locking tab, much like if you've inserted a PCI Express card into a motherboard, you'll see it has a locking tab. Again, LC uses both single and multi, push on, pull off, and uses a locking tab. MTRJ, again, single and multi, push on, pull off, and also uses a locking tag. FC is single and threaded to keep it connected. So you can see the example of how it is. They're both push in or twist. And simplex, duplex, and patch cables, you pretty much know. Simplex is single strand, duplex is 2 connected strands, and patch cables, important to note, can have different ends. This is a converter, so you can actually do Ethernet cable and go out to fiber. So you're going to do the in-class practice, which is a simulation. Understand your class discussion. Wiring. POA, pin out, LEC. POE is something that you're going to hear all the time. It stands for power over. If you look at your wireless access points, they're all power over Ethernet for the most part. They're hanging on a ceiling where there's no electricity. So it actually gets its power from one of the cables and possibly 2 of the cables in your Ethernet cables. Pin out, LEC, you'll see that. The demarc is very important. MDF, punch down block, and patch panels, also very important. So you can see PoE again is power over Ethernet. Pin out is how you're actually connecting the cables, the pairs. LEC is your local exchange character. And the demarc is actually where your building goes out to the internet through your ISP or comes in. And that's always going to be on a block of plywood. MDF is your main distribution frame. That's where all your equipment is, where your demarc is, and everything goes into there. Then you may have some IDFs in separate buildings. Punch down block, and you'll see a picture of that in a second, and a patch panel. The punch down block is normally on the back of a patch panel, but doesn't have to be. This is a separate punch down block over here, and this is a patch panel. And the patch panel is where you actually connect Ethernet devices from one you through a patch cable to the actual patch panel. Twisted pair, so you can see that you have 4 pairs, 8 strands. 1 and 2 is going to be for send. 3 and 6 are going to be for receive. The others are used either for grounding or for some other purpose that's needed, mostly for PoE. So you can see, depending upon whether you're doing an A or B type of cable, you'll see that in the next slide over here. This is straight through, meaning number 1 goes to number 1, number 2 goes to number 2. So this is going to be used for specific purposes. It's not normally used for computer to computer unless you have something that changes it, because the send on one computer is going to be the receive on the other computer. So you have to have a crossover. And you can see here pin 1 goes to pin 1. Crossover, you can see how pin 1 goes to pin 3, pin 2 goes to 6, and you can see 6 and 3 go to 1 and 2. So you can see the send here is the receive here, the send here is the receive there. And this is how the network cables. Now, you're going to hear some videos that are going to talk about whether or not to have a straight through or patch. All of the switches that you get should be auto sensing and do that for you. But normally, if you need to have one that doesn't have auto sense, you're going to have a straight cable going to one switch, and then a straight cable going to another switch, and then a crossover cable. But these are all done for you auto sensing. So if you have several switches in between, it gets very complicated as to which cable. That's why they're all now auto sensing. So you can see the difference between A and B. The most common is B. So you're going to look at green, green, which is going to be send, receive, receive. Here is send, send, receive, receive, and these are the same in both of them. This is what it looks like inside. And this is an RJ45 jack. These are instruments that you're used. This will do punch down both a RJ11 and an RJ45. This will cut the cable, and this will strip the cable. Again, you see just push it in and punch it down. This is a cutter and a stripper. This cuts, obviously, the cable. These are what they look like in here. So you obviously, the striped is different from the solid, and this is what it looks like. So you can tell from here, this is going to be 1, 2, 3, and 6. So I want you to look at this and determine whether this is type A or type B. And then this is what it should look like from the underside. Wiring distribution. Again, this is a demarc. Everything comes and starts here and goes out to the internet here. Then here you're going to have cables that link the different floors. And again, the service provider is responsible outside of the demarc. You're responsible inside the demarc. Okay, MDF over here. And you can have an IDF in several of the floors. These are IDFs. Vertical cross connect. This would be if you had another one over here. This would be a horizontal connect. And there it is, horizontal connect. And you have several horizontal connects. These are what the punch down blocks look like. So you can see how they're wired. Now, you're going to see numbers on these, and sometimes this is top and bottom, or sometimes they're 8 across. So you have to look at what it says on the punch stop block, and that will tell you exactly. This is what your patch panel looks like. So you're going to plug in 9 to wherever it is, and you should mark these over here so you know exactly where that's going to. So here is a practice exam. And again, discussions in here, more discussions. Troubleshooting, these are the things that you need to worry about. Look for EMI, crosstalk, attenuation, which is degradation of data, a short, which is something being admitted, and an open circuit is usually a break. So you can see here's the definitions that I've given you for each one. You can review them on your own. I'm not just going to read them. Understand that you need to know what attenuation is, loss of signal strength, and that could be the length of a cable or many other reasons. A short, when electrical signals leak, is what they normally call it. Open circuit, and it could also mean that you have a pin out wrong. You could have pin 3 going to the wrong pin. Here's troubleshooting tools. Now this is just extra memory, and this is just an extra cable that connects the SATA device to the system board, obviously system board, power supply, and a fan. This will attach to the motherboard, and the motherboard will sense the speed of the fan and will report it. Loopback pucks test to see if data is transferring and coming back. Cable tester will actually tell you the pinouts of your cable. So you plug the 2 of them in, and you'll see that 1 goes to 1, 2 goes to 3. And if that's correct, this will be the way it is, and it will pass. If they're mismatched, you'll see that. This is a cable certifier that will tell you if or not your table meets specific needs. Tone generator. When things are not marked, you can go into the port somewhere. You don't know where this computer is hooked up to. You plug one of these in here. You plug this into the port. Then you go in here, and you're going to go through the patch panel, and you're going to listen for a sound. And when the sound comes out, that's exactly where it's hooked up to. Again, you can do that from here, from either side, from the patch panel or from the punch down block. Multimeter is going to test a voltage and other things in your system board and in your power supply. Obviously, this is a toolkit which you need. Wire strippers, so you can cut, and this is normally for electrical wiring, so you can see 10, 12, 14 gauge, 16 gauge in here. Then you can look and see what kind of screw this is, and you can also cut it, the insulation. Wire cutters are wire cutters. And speed tests. I use Comcast speed test, and that gives a very good indication as to how fast you're going out. And you might look at this and see what's going on. If you're not getting good throughput, if you're paying for 50 megabits and you're only getting 25, you need to find out why. Again, more class discussions in here. And that's it for this video. Please let me know if you have any questions at all. So have a wonderful, wonderful day. Again, please excuse my raspy voice.